If you are new to Python, you're going to want to start with some Python basics. A quote from Gemini in 2024, "Python is a versatile and powerful programming language known for its readability and ease of use. It's widely adopted in various fields, including data science, web development, machine learning, and automation. Python's extensive library ecosystem and strong community support make it a popular choice for developers of all levels." On this tutorial, we just want to look at the basics to give a very brief introduction to Python. The basics of Python programming to learn include syntax rules, variables and data types, and operators. In syntax rules, Python requires proper indentation. The Python programming language is case sensitive. And you should learn how to write comments and understand the keywords of the language. For variables and data types, you should understand the rules for naming variables, how to declare a variable using the equals sign, and understanding the basic data types like integers, floats, strings, booleans, lists, tuples, dictionaries, and sets. And then understand some basic operators in the language. So operators including arithmetic operators, which are exactly what you would expect them to be: plus, minus, times, divide. Comparison operators, the double equal sign meaning equality, not equal to, less than, greater than, less than or equal to, greater than or equal to, mathematical comparisons, and then logical operators to perform logical operations. The operators and, or, and not are used in Python. Let's review some types. In Python, first of all, everything is an object, including data types and functions. This is an object-oriented nature of Python that allows for flexible and dynamic programming. Objects can have attributes and methods, and if everything is an object, that means everything can have attributes and methods associated with it. There are common data types in Python, including numbers like integers, floats, complex, strings, lists, tuples, dictionaries, sets, each with its own characteristics and operations. So let's go through a list, and if you're coming from another programming language, when we talk about types, declaring variables in Python does not require you to declare the type of the variable, but the variable is typed based on how you use it. So if you're coming from another language, that's one of the key differences in Python, is you do not have to declare variable types, but variables will have a type. It will be an object, and depending on how you use the object, what value you assign to it, will determine what its type is. And we'll look at that in a little more detail in a minute. But first, let's talk about the types in general. So the numeric types represent, the number type represent numerical values, such as integers, floating point numbers, and complex numbers. The string data type represents a sequence of characters. The list type is an ordered, meaning sorted in order, mutable sequence of elements, mutable meaning it can be changed. A tuple, it's like a list, but it's immutable. So again, it's a sequence of elements that is in order, but in a tuple, the elements cannot be changed. A set is an unordered sequence of elements, and it is an unchangeable collection of unique elements. So every element in a set is unique. So if you have a list of elements, a list of elements is a sequence, and that list can have repeated elements. If you take the set of that list, just like set theory in mathematics, you will get only the unique elements. So the repeated elements will have the repeated element removed. A dictionary is another data type. If you are familiar with JavaScript, a dictionary is going to look like a JSON object. It is an ordered collection of key value pairs. A Boolean type is either true or false. And there's a none type represented by the keyword none, which represents the absence of a value. If you're coming from databases or another programming language, you might think of this as null or nil, or NA, n/A, and that is Python's none. So before we go into looking at some code, I want to point to a couple of places to go to learn more about Python, starting with the official documentation. The official Python documentation provides everything you need to know about the Python programming language, and at different levels. So from the beginner's level to more advanced Python usage, you'll find everything you need to know in the documentation. To begin with, there's a Start Here tutorial. So the Python tutorial is a good place to start reading through the tutorial. And if you go through this entire tutorial, you can see it's rather long, but if you go through this entire tutorial, you're going to get a really deep picture of what the Python programming language entails, and that is going to prepare you to really get into Python programming and become an intermediate to advanced level programmer. But starting at the tutorial is a good place to start. The library reference provides a searchable reference that covers all of the different elements of the Python programming language. So the built-in functions, constants, data types like we talked about, and so on, you can find at the library reference. The language reference talks about the syntax of the language and the elements of the programming language. So you actually might want to start with the language reference and then move to the library reference. And in fact, the library reference is something to bookmark, because even after learning Python years later, you'll find yourself coming back and reading this documentation often. Certainly whenever there is an upgrade and new elements are added to the language, but oftentimes if you're doing something that you don't commonly do and you need to remind yourself what are the rules around that, you can find that in the library reference, which you should have bookmarked and use. There is a C component. There's a C API for Python that comes in handy if you're needing to do some very time-sensitive computations, frequently asked questions with answers, and a glossary of terms, which can be useful when you run across new terms. You'll notice there are a lot of versions of the documentation. Today we use Python 3. There is a big difference between Python 2 and Python 3. So when you're learning Python, it's important to remember, most likely you're learning Python 3. So it's important to remember when you're searching for information online that you are looking for information that is specifically Python 3, because Python 2 was around for a very long time. And we can see going back through the versions, you can see that there are very often releases made, and sometimes those releases give you new features, new things you can do with the programming language, but sometimes they make changes to older things and make it so that your code needs to be updated if those changes were not backwards compatible. And when we talk about changes that are not backwards compatible, there is a significant change between Python 2 and Python 3. So if you look at the smaller updates that have the same first number 7, or Python 2 or Python 3, then those are smaller changes, and those changes should be backwards compatible. But going from Python 2 to Python 3 was a significant change. And make sure that as you are searching for things online, I always point to the documentation, because that is your ground truth. That is where you want to go. And you want to look at the Python documentation for the specific version that you're using. Everything from 3.8 up is still very commonly used in practice, and there are some changes. So you'll want to make sure that the version of the documentation you're reading is equal to the version of Python that you're using. So familiarizing yourself with the Python documentation is very important to make sure that you are getting the right information and that that information is accurate and up to date with the version of Python that you are using. A tutorial that I like to start with is W3 Schools. You may have already learned some things in W3 Schools if you've been working in computer science at all or going to school for computer science. In W3 Schools, we have tutorials for a lot of different languages. For example, HTML, CSS, and JavaScript, all of the language of the web, is where this really began and then has expanded to include many other programming languages, including Python. So there's a really nice Python tutorial here at W3 Schools that I encourage you to work through if you are a new Python developer and you are just learning the language. And this is a bit shorter than the documentation, the getting started documentation in the Python docs. And the nice thing about the W3 Schools tutorials that I like is learning by examples and their try it yourself capability. So you can actually learn Python here and practice the things that you learned where you can actually change the code, run the code, and see the output. This is running a little bit slower than usual, so I guess depending on how busy their servers are, this may or may not run quickly for you. In fact, this doesn't seem to be running at all right now. Oh, here we go. There we go. So, and there's the new output. So this is a fun place to practice. There are, as you go through the tutorial, practice making small modifications to the code and running it again. If you're just looking for a place to practice online, there are a lot of online compilers. So if you just want to search for online Python compiler, you'll see there are quite a lot of Python compilers where you can practice writing Python online and executing the code. And this is a good place to get started so that you can really learn Python before you have to go deeply into setting up Python on your own hardware. If you have internet access, you have a web browser, start by finding one of these tools. They're all pretty comparable. I don't necessarily recommend one over the other, but you can flip through, just search for online Python compiler, search through the compilers that come up, find one that's comfortable for you, and you can use that to actually practice writing Python code so you can learn Python without going through the pain of making sure that you have installed Python on your system. Of course, when you're ready to work offline and save your own code offline, then you're going to want to get into setting up Python on your system. But when you're just learning, go ahead and start with an online compiler just so you can practice writing the code and learning to write Python. I have included a couple of example scripts, and this is just to give you the basics. So variable declarations and just some small statements to use, print statements so that you can output things, and some operators. So let's look at, so you can copy this code and run it. And again, you can copy it and run it in any one of those online compilers. You can copy it here, paste it there, and run it. But I want to leave this page now and actually do write some Python coding with you. Python developers have a lot of choices of how they want to write their code. After you've moved from practicing Python in an online environment and you have Python set up on your system, the next question you ask yourself is, what program do you want to use to write your code in? I personally prefer to use a simple text editor, and I choose a text editor that does what we call syntax highlighting. You can use a plain text editor. Python is just a language, and as a language, just like the spoken languages, you can type the words using the syntax of the language, and you can type them anywhere. But if you want to be able to execute the code when you're done, you need to give it a .py extension, and it needs to be a plain text file. And so you should use a text editor to write that code. There are text editors that are plain text editors, and then there are text editors that they're still plain text, but they do code highlighting. So they add some colors to just the visualization to make it easier to see, and also have features like autocomplete and things like that to help you write your code. In addition to writing in a text editor and executing your code at the terminal, at the command line, you might want to use an integrated development environment. Python has a lot of IDEs that are available. Some popular ones include Spyder or Anaconda or even VS Code. And that really comes down to a personal choice, whether or not you just want to use a text editor or you want to use an IDE. When I talk about an IDE, it's an integrated development environment. So here where you see I have my text editor open here, and then I have my console. In the Mac, this is called Terminal. And this is a command line. This is where I can execute commands. For example, ls gives me a list of all the files on the desktop where I am. And I see there's a file there called intro.py, and I currently have that file open in my text editor. My text editor of choice is Sublime Text, so this is Sublime. If you choose to use an IDE, one of the IDEs that are available, you're going to find that your text editor and your command prompt are combined in the same app, and that app will provide different ways to install packages. And we won't go into the details of that today, but I'm just letting you know that I prefer to use a text editor. So throughout this tutorial, I'll be using my text editor to write the Python code, and then I'll be using my terminal app, my console, to execute the Python code. But when you're using an IDE, the way that you execute the code might be slightly different, but the code remains the same. Remember, Python is a language. So the way that you write the code is going to remain the same whether you're writing it in a text editor or in a text editor that's embedded in an IDE or an online format where you can type your Python code. It's all the same Python code no matter where you're putting it, because Python is a language. So try not to confuse the Python programming language with whatever application you are using to write your code. So let's start by writing some Python. So I gave you some examples on the web page there, but let's go ahead and type some of these out. So for variables, we can declare variables. A variable name, there are a subset of rules associated with what you can name a variable. And in general, we like to keep our variables lowercase and short, but long enough to be descriptive. My personal style is to use variable names for mathematics to be single letters if I'm going to store numbers. But if there is something that I'm going to store where later I want to reuse that variable and I need to remember what it is, I may use a short word. And so you'll kind of see my programming style come out as we go through this. But a variable name, as long as it follows the rules for creating a name in the language, you can name things pretty much anything you want under the rules. And the rules are very, they're not very strict. So you can look that up. In fact, I don't even remember the rules because it's never really come up. I think a variable name cannot start with a number is one of them. And certainly there's no spaces. You cannot have spaces in your variable name. I'm going to use the variable x, and you can see my text editor is making suggestions for me. And so your app may make suggestions for you as well. If we want to assign a value to a variable, we use the equals sign. So I'm going to establish a variable x. So if you remember, like your algebra classes, we used letters to represent numbers for variables. So we can say x equals 7. So x is a variable and 7 is the value that has been stored in that variable. So right now, the value of x is 7. And that type then of x will then become an integer because 7 is an integer. I'll create another variable y, and this time I'll give it a floating point value. So y equals 3.14. Now y is going to be recognized as a floating point type, so a float. You can also store strings. So another type we talked about was string. So my first name is Tony. To represent a string in Python, you simply need to put it in quotes. And in Python, you can use single or double quotes, your choice, but you should be consistent throughout. So make a choice and stick with it throughout your code. I tend to use single quotes with Python, but then double quotes in other programming languages that require double quotes. But if I have the option, I prefer to use single quotes just because it's slightly easier to type. And so putting something in quotes designates it as a string, and a string can be any sequence of characters. And so those characters can be letters, numbers, spaces, any typable character, any non-printable character that you can represent with a character code. In this simple example, the string of characters is a string of letters that represent my name, and I'm storing it in a variable that I have aptly called name. The other another string might be the title of something, learning to code. So see here, you'll see in my string, I'm putting spaces, and spaces are perfectly fine within a string, but remember, you never want to use spaces in your variable names, and you want to be aware of spaces and indentation in your code itself. So we won't go into that level of detail in this particular video. We'll just do some simple examples. So we have some numbers here. In Python, if you want to write a comment, these are called code comments. If you put a hashtag at the beginning of a line, when this code is executed, that entire line will be ignored wherever the code is executed. That line will be ignored. So that we use the name comment to specify what that name is, because it is a comment from one programmer to another programmer, or back to yourself. It's a comment saying something about the code that is meant to be human readable. It is not meant to be machine readable. It is for humans looking at the code to read. So the machine is going to ignore any line that starts with a hashtag. So you can write anything you want in there. And I'm going to say that these are numeric types. So this is just a comment saying that these next couple lines of code represent numeric types. I can make another comment here saying, these next lines of code represent string types. We also have Boolean types. And a Boolean type, if you recall, I said Boolean is either true or false. So that can store values, be used for variables like complete or done, meaning I'm not done yet. I haven't completed my program yet, so I'm going to set complete equal to false, and then maybe later in my code I will change it to true. False and true need to be capitalized. Those are keywords in Python. You may have seen them in other programming language if you're coming from other languages, and the key to remember there is that in Python they are title case, so capitalized, the beginning letter. There are also list types, and list comprehensions are one of the things that Python excels at. So we won't get into list comprehensions today, but we will get into lists. And this may, you may recognize this as an array from math or perhaps another programming language. When you are creating a list of elements in Python, those elements can be of any data type that you want to put in your list. So I create a list of letters to go along with my list of numbers, because letters are strings They're characters. I need to put those in quotes. And this is a letter, this single letter is just a string. It is a string with a single character in it. Of course, in Python, you can also have mixed types and lists. And this is not true for all programming language. Some programming languages require that a list or an array only contain the same types, but a Python list is more flexible than that. So you can have multiple types within the same list. Tuple is another type we mentioned. And the difference between a list and a tuple, if you recall, I said that lists were mutable, meaning lists can be changed. So the values of the items in a list can be changed, whereas tuples are immutable. And the syntax for that is slightly different. So I'll go back to my example code here from the website. I used colors to represent a tuple. And so in this case, these three values in this order cannot be changed. They're immutable. And notice the syntax was slightly different, using the curly braces versus the square braces for the list. And then there's also the concept of a set, and items in a set are unique. And to create a set, you can use curly braces and then list your items. So for example, hat, shirt, and socks, that's one way to create a set. And then finally the dictionary, which I mentioned is similar to a JSON object in that it's a sequence of key value pairs. And the dictionary example I have here is data. Again, my variable name could be anything I want. I'm choosing data. The syntax for a dictionary, like set, open and closes with curly braces, but unlike set, instead of having a comma-separated list of elements, you're going to have a set of key value pairs. So the syntax for that is to first write the key and then give the key a value. And the key value pairs are separated by commas, and the key and value itself is separated by a colon. So we're going to create a data dictionary, a dictionary named data about the planets in our solar system. So we have 8 planets, we have 1 sun, and the largest planet, spotted a typo in my code on the web there to fix, is Jupiter. So you'll notice that I'm using numbers and strings as values here, and remembering that string has to be in quotes. Incidentally, if I were to put this number in quotes, it becomes a string. It can now no longer be operated on as a number, meaning numerical operations are no longer going to work because it is now a string. And you'll notice that my text editor did syntax highlighting, and it's making all of my numbers purple and keeping my strings yellow. So that's an example of a dictionary. All right, so let's go into some examples of actually creating output. So when we run this code, we can actually see some output, and I will look at just a couple of the operators while we're here. The print statement is your friend. So while we haven't talked about functions yet, the print function is one that you will use anytime you want to print output to the console for viewing. And the syntax for that is print, which is the function name, and then opening and closing parentheses. And then within the parentheses, you need to put a string. So this needs to be the string that you want printed to the console. Now, for example, if I were to say, if I were to include a number here, the number would get converted to a string and output to the console that way. If you recall X and Y, scroll back up to the top, those were both numbers. X was 7, Y was 3.14. So X and Y are numbers. Numbers can be summed together. Numbers can be subtracted. Numbers can be divided. So we'll sum those together, and we'll print the outcome. You can also do your math and store it in another variable. So this would store the value in the variable z. So that's another way to do it. And then I could just print the variable z. There's another example there. The spaces here around the operators are not required, but for readability, I think sometimes it makes it a little easier to read. So we can print the result of adding x and y. Incidentally, the plus operator also works between strings. If I were to use plus between two strings, for example, hat and shirt, since those are not numbers, they cannot be arithmetically summed. What happens with strings is they get concatenated together. So if I were to say hat plus shirt, I would get a single word, hat shirt. So that's just an interesting tidbit about the plus operator. Of course, there's a lot more details. Here we're just going to continue on with some very minor basics. Is x greater than y? Greater than, less than, equality. When you use those symbols, that expression is going to resolve to either true or false. And here I'm just going to print out whether that was true or false. I talked about equality being two equal signs because remember, a single equal sign is used for assignment, assigning a value to a variable. So I'm going to use two equal signs to ask if two variables are equivalent. So does x equal y is the question I'm answering there. I'll print the output of that. And before we continue, let's go ahead and run this and see where we're at. So I've named my file intro.py. So remember, a Python script needs to end with a .py extension. I have it stored on my desktop here. So I'm going to go to my terminal, so my console, and I'm going to type Python because I have Python installed on my system. And on my system, I have Python 2 because I have a lot of legacy code that used Python 2. But then I also have Python 3. So the way I have set up my operating system, if I type Python, it executes Python 2. I need to type Python 3 to execute Python 3. And that's a common thing that Mac users do because your Mac came with Python 2 pre-installed. And if you want 3, you need to install it yourself. And if you want to keep both on your system, then this is one way to distinguish between 2 and 3. But typically, you'll probably just type Python as the command to interpret your code, and then followed by the name of your script. So my script is intro.py. So I am calling the command Python 3 and saying execute intro.py. And my 3 print statements are output. So the first statement, z, was x plus y, 10.14. The next statement, x greater than y, printed true. And the next statement, x equals y, printed false. So the print statement is something you should definitely be practicing with because otherwise you don't get to see any output from your code executing. From my data dictionary, I can print a certain element from the dictionary. To access a dictionary, we use this syntax where we put the name of the dictionary, followed by opening and closing brackets, followed by the key that we want to get the value from. This should print the value of planets. Planets was my key. It should print 8. Go execute my code, and I can see of course, all the print statements executed, and the last one printed 8. And then formatted strings is the last thing we'll talk about in this lecture. As you're practicing creating variables and assigning values to them, when you're printing and you want to include the variables in a string that you're printing, so we could certainly print a string by itself. So this can be, well, first let's start with, we can print a value that's stored in a string. So I had the name string up here that had the value Tony. Or I can simply print create the string right there in the print statement. I'll save that and run it. And we can see that we printed Tony, hello. So name resolved to Tony, and that got printed. Hello was a string that I hard-coded into and fed into the print statement. And that brings us to the last thing I want to talk about is what if you want to combine the new strings that you're creating with variables that have variable values, string values, or even numeric values stored in them. We use what's called an F string. So remember I said a string has to open and close with either single or double quotes. If you put a lowercase letter f before the opening quote, then you can use a syntax that allows you to put variables in your string. So I'm going to create a longer string that says, hello, I am, and then instead of typing my name, I'm going to use open and closing curly braces, which allows me to use a variable name. So the variable is name. That's going to resolve to my name, Tony, and it's going to fill in that value at this point in the string. And I will say this is title. I stored a title up above. I don't remember exactly what it was, but we'll see it when we print this statement. So I'll save my code again and execute my code again. Hello, I am Tony. This is Learning to Code. So you see my name got filled in there and the title got filled in there. So F strings are very friendly and easy to use because they make it so that you can write a string that is easy to follow as you, the developer, are reading the string, but then still use variable values. So at any point in my code, if I were to change the name, this is going to now print Bob because I changed the name, I reassigned that value. So F strings are very useful when you're printing statements, and with everything we covered today, creating variables, assigning values, looking at the operators that are available to you, and the different types, that's a good starting place to just start practicing with writing code and using the print statements to print some outputs and perform operations so that you can see what those outputs look like. So enjoy starting your practice and learning Python, and check back for some more advanced tutorials as we continue to work through learning how to code in Python.